Hello, my name is Courtney Payne, Associate Editor at ASHRAE Journal. Thank you for joining us for today's webinar, part of the High Performance Buildings Supplier Webinar Series to provide information of interest to HPB magazine readers and others about products and technology of interest to industry professionals. ASHRAE does not review supplier webinar presentations. The following presentation has been prepared by Automated Logic on the subject BACnet Secure Connect, What You Need to Know. Today's speaker from Automated Logic is Ken Gilbert, Regional Technical Consultant. Ken Gilbert supports design engineers and consultants in the Atlanta area and brings significant industry experience to Automated Logic, having served with the Train Company and Honeywell International in a variety of sales, engineering, and consultative roles. Ken graduated from the Georgia Institute of Technology with a Bachelor of Science degree in Industrial Management. Ken, the microphone is all yours.
Thanks, Courtney. Hello, everybody, and thank you for spending some time with us today. Today, we're going to talk about the subject of BACnet Secure Connect, or BACnet SC. For those of you that are interested in obtaining continuing education credit, Automated Logic is authorized by ISET to offer those CEUs. All you need to do is send me an email, ken.gilbert@carrier.com, requesting that credit, and I will send you a link to our learning management system where you'll log in, take a short quiz, and then you'll be able to download your certificate. So today, what are we going to talk about? So today we're going to talk about BACnet connectivity and BACnet IP. We're going to talk about what is BACnet Secure Connect or BACnet SC. Why do you need BACnet SC? And then how to implement BACnet SC in existing and new installations. So BACnet is short for Building Automation Control Network. Development of the BACnet protocol began in 1987. In addition to becoming an ANSI standard, it also became an ISO standard in 2003. And BACnet is under continuous maintenance by the ASHRAE Standing Project Committee 135. BACnet is a standard data communication protocol that enables interoperability between different building systems and devices in building automation and control applications. The BACnet protocol provides the means for many kinds of basic and complex interoperations to take place using standardized techniques that have proven to be flexible and robust for almost 20 years of practice in tens of millions of devices. The method of testing conformance for BACnet was published in 2003. In 2012, the BACnet standard defines 7 network types which serve as the transport layer for the BACnet messages. The 7 supported network types are BACnet Internet Protocol, or BACnet IP, BACnet MSTP, Master Slave Token Passing, BACnet ISO 8802-3 or Ethernet, BACnet over ARPANET, BACnet Point-to-Point, which is EIA 232 and telephone. It also provides BACnet over lawn top form frames. BACnet allows the transport component of lawn talk to be used to carry BACnet messages. However, the 2 protocols are not interoperable. And then the last one is BACnet Zigbee. And traditionally, we have seen Master Slave Token Passing, or MSTP, on Twisted Pair as a preferred BACnet protocol implementation. And a lot of that was due to the fact that the BACnet IP, or the transmission protocol, internet protocol, was expensive and not available for smaller devices. But today, installations are implementing the BACnet IP protocol. So BACnet over IP is becoming more popular today because the cost of implementing BACnet IP has come down. In addition, there's a movement in the industry to connect multiple building systems, building automation, lighting, access control, together using standard IT practices. And the movement has also been going from a decentralized data system management to a more centralized data management. So if you see on the slide there to the left is where things kind of are today, where there are data silos, if you will, for each system. And we're moving to where there will be a data lake or common data silo for all of these systems to converge and talk with each other. As the movement to IP connectivity has grown, the traditional IPv protocol that has been used presents some limitations. So BACnet IP has been moving from IPv4 to IPv6 protocol. IPv4 has been around since the early 1980s, and IPv4 addresses comprises 4 numbers, each ranging from 0 to 255. So these would be the traditional IP addresses that you're used to seeing, like 192.168.10.1. The issue is IPv4 has a theoretical limit of 4.3 billion addresses. As the internet has grown and we have moved into the age of the Internet of Things, we've run out of addresses. Savvy IT professionals have figured out ways to reuse addresses with masking. IPv6 was introduced in the late 1990s. IPv6 uses 128-bit addresses represented by 8 groups of 4 hexadecimal digits separated by a colon. So example, 2002 colon ODE6 colon 0001, et cetera, et cetera, et cetera. So the IPv6 schema allows us to provide 340 undecillion addresses. IPv4 and IPv6 can coexist together on the physical layer or wire, but older IPv4 devices do not typically support IPv6 protocol. So now let's take a little bit and talk about BACnet IP connectivity and the topology. So the big question is, where are the devices? Do we have IP everywhere? Some people say, I want everything to be able to talk to the cloud, or I want everything to be visible and managed by standard IT tools. IP addresses are expensive and a pain to get from IT, so I want as few as possible, but I still want to get my data to the cloud. So how do we do that? We use BACnet IP, and now then comes a conversation, do I want daisy chain or home run? Home runs are direct connections between the IP devices and the switch. And the daisy chain is a connection from the switch to an IP address, and then it goes to another IP device, if you look at the slide there on the right. But some of the issues with having IP connections on every device, IP charges you per port on their managed switch. Then you have to weigh reliability versus the cost, and then what policy dictates individual manageability. So that brings us to the building Internet of Things, or BIoT connectivity. The building Internet of Things cloud model has every device with an IP address speaking directly to the cloud, but not to each other. And just so you know, the definition of the Internet of Things is a system of interrelated computing devices, mechanical and digital machines that are provided with unique identifiers and the ability to transfer data over a network without requiring human-to-human or human-to-computer interaction. So when we move to the cloud, the traditional phone home model has been used in the past. And what happens here is devices are connected to a cloud, and the only way that you can interact with those devices is through the manufacturer's cloud. So the advantage of these clouds is it's client-only devices, so that reduces the attack surface from hackers. It's easier to manage security and who can talk to whom, but then you have some scalability concerns. How many simultaneous users can access the system. So then another aspect is a peer model, where every device has an IP address and they're able to speak directly with each other. So you can see here we've got IP devices across the bottom, and then they're able to talk to each other, not just to a cloud. The advantage of this is it allows fast interaction, it's reliable without cloud dependency, but then security becomes more difficult to manage. And this is a typical installation that we see with building automation systems and BACnet IP devices today. And as I mentioned before, this implementation requires IP addresses for each device, and many times the addresses are required to be static addresses. So how do they talk to the cloud? So the hybrid model allows devices to interact with each other and with the cloud. And then non-IP devices can interact with the cloud through another device that's on the IP network or through a gateway or server that connects it to the cloud. The advantage of this hybrid model is it maintains fast, reliable interaction for local control. You're able to move data to and from the cloud for higher level functions. And then you communicate to the cloud either directly or through an edge processor, concentrator, or digester. So the data connectivity is also split. So when you talk about the Internet of Things, you are in a situation where you have a client-only publish-subscribe model, which you see in the lower right, or you have a client-server model, which you see on the left. The advantage of the client-server model is the client is only receiving the information that it needs to see, whereas in the publish-subscribe model, information is published globally for all of subscribers to see. So with a client-only type arrangement, the client, in this case Alice, can't send a message to a server Bob if he's behind the firewall, and then vice versa. Server Bob can't send a message to client Alice sitting behind the firewall. The issue here is most IT organizations manage firewalls and prefer information to be going outbound. In other words, from the protected network outbound to the external network. So a way to solve this is to implement what's called a trusted middleman. And that's what brings us to BACnet SC or BACnet Secure Connect. BACnet Secure Connect was an addendum, it's addendum BJ, that was issued to ASHRAE Standard 135-2016 that was published in November of 2019. BACnet SC is the first addendum to the BACnet standard that can be applied to previous versions of the standard. This means that older devices, if capable, can be updated to speak BACnet SC without revving them to the latest revision of the standard. This implementation is expected to accelerate the introduction of BACnet SC products into the market. So what is BACnet SC? BACnet SC is a new data link that eliminates many of the security concerns owners, facility managers, and IT professionals have with BACnet networks today. BACnet SC provides the means to create secure communications between building automation devices across the cloud and within facilities. It uses standards that are accepted by the IT community. It's based on standard TLS 1.3, and it does this using WebSockets that use the Transmission Control Protocol, or TCP, versus in the past where we've used User Datagram Protocols, or UDP, to establish a communication channel. Transport Layer Security 1.3 security has options for 128-bit and 256-bit elliptic curve cryptography. Another advantage of BACnet SC is no static IP addresses are required. This reduces the burden on IT groups and may decrease installation and lease costs to users. I had a situation here in Atlanta with a customer. The IT department actually charged for every IP drop that was used, and then in addition to that fee to install it, they also charged a monthly leasing fee. So be aware of that. When you're dealing with BACnet IP installations. Real quick, I guess, Austin, can everyone hear me better now? I tried adjusting my speaker. I guess there were some issues hearing me. Okay, great. The other advantage of BACnet SC is the elimination of BACnet broadcast management devices, or BBMDs, and the need to keep them configured to match network topology. There's no more broadcast distribution tables. So you can see up here on the right, this is a typical table that would be set up in a BBMD. And what happens with the implementation of the BBMD, I have had this happen, if the IT department decides that they want to implement some sort of new IP addressing scheme or network topology, all that stuff has to be changed in the BBMD, and then all the static IP addresses involved with that. It becomes a little bit of a hassle and burden managing that network. Basically, BACnet SC is a virtual data link that bundles the BACnet network and application layers to become an application. The application is linked to the application layer with WebSockets through HTTPS. A WebSocket is a communication protocol providing a two-way communication channel over a TCP connection. The WebSocket keeps the connection open and allows the client and server to securely send and receive information. The BACnet SC standard requires the use of common IT transport layer security using the TCP protocol, and this provides the security. And at the link layer, any data link technology possible that supports IP or IPv6 can be implemented, whether it be Ethernet, wireless local area network, 4G, 5G, etc. BACnet SC uses a hub and spoke technology. The devices find the hub with a standard DNS lookup of the hub's URL. DNS is a domain name system, or Uniform Resource Locator, URL, which is better known as a web address. The devices can be on separate IP subnets or anywhere on the planet. The devices communicate to each other through the hub, and we've got some diagrams coming up that we'll look at. And then for efficiency, the devices can actually talk directly to each other after meeting on the hub. And like I mentioned before, what ends up happening is the BACnet SC hub becomes that trusted middleman that we talked about before that relays the messages. So now we're going to take a little bit and talk about the BACnet SC hub and spoke topology. So BACnet SC uses a hub and spoke technology where a single central hub device manages or directs traffic to another node or all nodes. And a node can be a thermostat, a workstation, or even an existing BACnet system. BACnet SC provides a detailed failover mechanism to keep the system up or online. If the primary hub fails or is taken offline for maintenance purposes, all BACnet SC nodes are mandated to support reconnecting the BACnet SC failover hub. So if the primary knows it's going down, it can tell all the devices to immediately connect to the failover. The failover monitors the primary and will send everyone back to the primary immediately when it becomes available. This is designed to minimize downtime in critical installations. It's probably not going to be needed for typical installations, but it is something that is spelled out in the BACnet SC addendum. BACnet devices on a BACnet SC network must use the same primary hub, but the devices can use a different failover hub. And then regular nodes can perform direct connection to other regular nodes in addition to going through a hub. So let's take a second and just look at the pictures here. On the left-hand side, we see an installation with a primary hub and then the BACnet SC nodes connecting to the primary hub. Then in the middle top, we see a situation where the failover hub. And on the right-hand side at the top, if the primary hub fails, then the device is moved to the failover hub. And then you also have the capability with BACnet SC devices to allow direct connect to other SC devices on the primary network that the hub serves. I want to point out the primary hub is required. The failover hub is an optional device that's not required in all installations. So BACnet SC uses mutually authenticated TLS or transport layer security. The hub authenticates the devices and the devices authenticate the hub, and they both share a common certificate authority. So the TLS protocol provides communication privacy and integrity. The TLS connection between client and server requires one or more of the following. One, a private or secure connection that's based on a shared secret or key from the certificate authority negotiated at the start of the session. Number two, identity of communicating devices is authenticated using public key cryptography. And number three, reliable connection by using a message authentication code to prevent message loss or alteration. So with mutually authenticated TLS, the server is authenticated by sending a digital certificate to the client. The client verifies the server's certificate by using a certificate authority. The client is authenticated by responding to a certificate request from the server with a client certificate message. And the server verifies the client certificate and then authenticates the client. So now you're probably asking, why BACnet SC? So with BACnet SC, the good news is you can do it yourself. You don't have to have IT involvement. The bad news is you're still going to have to do it yourself, and IT might still be involved. So with BACnet SC, you can establish secure tunnels without the need for virtual private networks or virtual local area networks, VLANs and VPNs. You're also able to assure customers that you're using standard state-of-the-art TLS, and the current TLS is 1.3 today. You protect not only the connections across the internet, but also within the building. And then the really great news is this can be implemented on existing BACnet networks. So BACnet SC is firewall friendly. It does not connect, devices connect outbound to the hub. There's not inbound connections. In other words, connections from the World Wide Web coming in. The hubs connect outbound to other hubs. Only the hub has to be reachable. The devices do not. And then there's no IT involvement for port mapping or making holes. And port forwarding or port mapping is an application of network address translation, or NAT, that redirects a communication request from one address and port number combination to another while the packets are traversing the network gateway, such as a router or firewall. This technique is most commonly used to make services on a host residing on a protected or masked internal network available to host on the opposite side of the gateway or external by remapping the destination IP address and port number of the communication to an internal host. And then firewall is a network security system that monitors and controls incoming and outgoing network traffic based on predetermined security rules. And a firewall typically establishes a barrier between a trusted internal network and untrusted external network or the World Wide Web. So making a hole in the firewall allows for inbound traffic from the external network based on predetermined criteria. So the disadvantage with port mapping and managing firewalls, it makes network management more complicated. So with BACnet SC, you eliminate some of those complications. So with BACnet SC, no IT is needed. The deployment and the flexibility that you use is up to you. You can have hubs in the cloud. And when I say hubs, the primary hubs are failover hubs. You can have them in buildings. You can have them in routers. The location and number of failover hubs, and like I said, you could have 0 that are not required. You can scale up with big hubs or route between multiple SC networks. So this makes BACnet SC very scalable. You use standard HTTPS port 443. So ports are used to connect to a server. So the traditional hypertext transfer protocol, or HTTP, has been used in the past to connect the server using port 80. And in this port, data is sent and received in plain text. With Hypertext Transfer Protocol Secure, or HTTPS, it's a protocol that uses TLS to encrypt data using port 443. And port 443 is the standard port for this secured HTTPS traffic. And you may have seen, when you type into websites, you may see the HTTPS abbreviation in the address bar. This is a website that's using the secure transfer protocol, and it's typically using port 443. And then, as I mentioned before, no virtual private networks or virtual local area networks or fireholes or port mapping are required. However, BACnet SC is also to be IT friendly for cases where it does require IT involvement. So in the previous no IT examples, you were the certificate authority and you issued your own TLS certificates for the customer's private key. In large installations, the customer's IT organization owns this role and is in charge of issuing the certificates. So with BACnet SC, you can do it either way. You can manage it and do it on your own, or you can involve the IT department and have them involved with managing the certificate. This also works where one incumbent HVAC contractor has been issuing their own certificate and then needs to issue them to a newcomer. And the reason being is the owner is going to be the certificate authority. So the certificate authority is an entity that issues digital certificates. A digital certificate certifies the ownership of a public key by the named subject or owner of the certificate. And this allows others to rely upon a private key that corresponds to the certified public key. A certificate authority acts as a trusted third party trusted by the subject or owner of the certificate and the party relying upon the certificate. And the digital certificate is what is used to establish the secure connection between a server and a client with TLS. So what ends up happening is the certificate is shared between the devices when they first make their connection or start their session. This is real important. The certificate authorities must be owned and managed by the customer, not the BAS contractor or whatever other system you have installed that uses BACnet SC. You as a customer need to make sure that you own that certificate authority. In the addendum, YY 7.4.1.2 requires the signing certificate authority shall be controlled by the site, aka the customer. So you, on behalf of your customer, are the certificate authority as an installing contractor, and you issue your own TLS certificate, but the customer still owns the certificate authority that you're using. It belongs to the customer. So now I want to take a few minutes and let's talk about how to implement BACnet SC. So on your screen right now, it would be a new implementation of BACnet SC with everything in the facility. So you can see you have the BACnet SC devices using the BACnet SC protocol, which is in green, and then a primary hub, a failover hub, and then the server that's managing whatever system, whether it's a building automation system or lighting system. So a couple things that I want to point out here. These primary hubs and failover hubs, these could be something, these could be a physical piece of hardware, or it could be a software device as well. It doesn't necessarily have to be a physical piece of hardware. But you can see it resides on the network, and it talks BACnet SC. And just so you know, the BACnet SC, like we mentioned before, is really nothing more than a virtual data link or protocol that talks on an existing IP network. So an existing installation or even a new installation, if you're just using Cat6 cable, BACnet SC talks across the Cat6 cable. If you're doing a wireless installation, the BACnet SC protocol is going to be talking across the wireless medium. I just want to point out that there's no physical changes that need to be made to the network media to transmit the BACnet SC protocol. And this slide here, this is an implementation that is cloud-based. And you see we have the cloud here on the right, a firewall. And if you'll notice, we have a server that's in the cloud, a primary hub that's in the cloud, and then the failover hub that is in the building. And you can see in green here, we have the BACnet SC protocol talking to each other that communicates to the primary hub through the cloud. Here is an existing BACnet SC implementation. So what I want to point here to here is on the left, if you'll notice, there is blue with BACnet IP devices. So if you have existing BACnet IP devices sitting on an IP network, a BACnet SC to IP router is installed. So BACnet IP is talking from the devices that are on the left to the BACnet SC IP router that's at the top. And then the BACnet IP router is talking the BACnet SC protocol, which is in green, through the firewall to the primary hub in the cloud and then the servers in the cloud. And then you'll notice across the bottom, we have existing BACnet MSTP devices. And those can be added to BACnet SC by installing a BACnet SC to MSTP router. So if you'll see here, talks BACnet SC protocol. And let's say in this instance here, we were adding another air handling unit to this installation. We would simply just add another BACnet SC device on the network, and then it would talk the BACnet SC protocol, which is in green, back to the primary hub. I just want to go back and re-emphasize that this is using the physical network media that is in place. So if it's Cat5, Cat6, or wireless, you're still using that physical media, but now instead of talking an IP protocol, like over here on the left in blue, you talk an SC protocol that talks to the primary hub that's in the cloud. And as I mentioned, these primary and failover hubs, the primary hub could be behind the firewall on the left within the building, or it can be in the cloud. And then the same is true with the failover hub. And then once again, I want to mention that the failover hub is optional, it's not required. So for some more information, you can go to the ASHRAE website to find out information about the BACnet standard and the addendum for this standard. Another source of information is BACnet International. It's BACnetinternational.org. And one of the things that I want to talk about here is on this website, there is a program that has rolled out this year that's called the BACnet Secure Connect Interoperability Acceleration Program. And on our right here is a list of manufacturers that are involved with this program. And basically, this program is to help manufacturers share knowledge and skills to implement BACnet SC in their products and solutions. In addition, this program will enhance the interoperability of their BACnet SC devices. So I'd really encourage everyone to go to this site to learn more about BACnet SC and what manufacturers are involved with BACnet SC. So some key takeaways. Building automation systems are becoming IP-based. And as I mentioned, we're moving more from the IPv4 to the IPv6 protocol. Traditional BACnet systems are not cyber secure installations. BACnet SC provides the cybersecurity that's required by IT organizations using modern IT standards. And then BACnet SC is a scalable implementation that can be applied to both new and existing installations. And once again, I want to point out, if you do need the continuing education credits, that's my email address on the lower right, ken.gilbert@carrier.com. Just send me an email. And with that, we will turn it over for questions.
Thank you, Ken. We do have several that have come in, so I'm just going to start with this one right here from Brian with Lockheed Martin. Can BMS servers be hosted in the Cloud Connect to end IP devices without concern?
Okay, can you read that to me one more time?
Sure. Can BMS servers be hosted in the Cloud Connect to end IP devices without concern?
Using BACnet SC, yes, they can.
Okay. Next up from David McDowell.
And I guess let me add to that. So in order to accomplish that, if you were doing a new installation, the new devices would need to be BACnet SC devices that you're connecting to. If you're in a situation where you have existing BACnet systems, like we talked about in this slide here, you need to put in BACnet SC routers to whatever protocol, whether it's MSTP or IP, and then those devices would talk to the server and do that through BACnet SC.
Okay, thank you. And this question from David McDowell: does BACnet SC allow for automatic buffering of data to prevent data loss?
Justin, you might want to weigh on that. I know that with BACnet SC, the data is monitored to make sure the integrity is maintained so that you're able to detect if there's any data loss or data modification. But in terms of buffering, I'm not sure. I would have to research that and get back to you, Justin, unless you have any input on that.
The buffering is typically a function of the switch or the controller, so it's not really a function of BACnet SC. So the protocol itself won't buffer any data. That's going to happen at your switch level or the controller level. So I hope that answers your question.
Okay, thank you. Our next question comes from Tarana. After the devices meet at the primary hub, the interaction between devices, if direct, is independent of the hub. So if the primary hub goes down, the established direct connection stays?
Correct.
Okay. Next question from Claude Novauer. When will BACnet SC be fully approved and implemented?
So as it stands right now, BACnet SC is approved. It was an addendum that was issued to the BACnet standard in November of last year. So it is an approved protocol. And manufacturers are now in the process of adopting the SC protocol into their devices and solutions that they're offering to the market. And then that's one of the reasons that there's the early adoption acceleration program that BACnet is hosting to try to drive this implementation and get it to the market quicker.
Okay, great. Next question from Stefan. Is it recommended to look at moving from a VLAN solution to BACnet SC, or is this better to be used in a net new scenario?
Well, I think that's going to be a function of your IT department and their requirements. My initial thoughts would be if you do not want to have the issues of managing VLANs and what goes along with that, then BACnet SC would be a great implementation into an existing network to manage your BACnet networks.
Okay, next up we have a question from Cullen. Is there spec language that an owner can add to their automation specifications to ensure that the owner be the certificate authority?
I guess I would add that very direct language. And if you wanted to, you could even reference the section that I mentioned that's in the BACnet SC addendum. I'm trying to find that again. That was bear with me 1 second. Yes, the actual section in the addendum is YY.7.4.1.2 of the addendum. And like I said, it requires the signing certificate authority shall be controlled by the site.
Okay, great. Next up, a question from Tony. Do the BACnet SC to MSTP or to IP routers require a lot of programming or setup?
Frankly, that's going to be dependent on the manufacturer. I'm not sure how other people are going to be implementing those devices. So I'm not sure. It's going to be dependent on whose device it is.
Okay. Next question from David. Will controls contractors be forced to start using BACnet SC, or will users/designers have to specify the SC version of BACnet?
So users are going to need to start requesting it, and designers are going to need to start requiring it in their design documentation to implement it.
Okay, next question from Akila. The question is, with BACnet SC being approved, is BACnet IP going to be phased or discontinued?
So I think the short answer to that is I think that we will see an industry movement from BACnet IP to BACnet SC devices because they will provide the security that's required by IT departments and what owners and facility managers are going to want in their buildings. So the short answer is yes, I think we will see that happen, but how long it takes for that to happen, I'm not sure. I would say it's going to be a few years just because of the number of BACnet IP installations that are out there right now.
Okay. Next question is from Ricardo. What's the difference between the hub and server?
So the server would be the server that is running the, let's say, the building automation system. The hub is nothing more than, like I said, it could be a software device, it could be a hardware device, but basically it's a node, if you will, on the network that provides the encryption of the devices on the network between the hub and the devices that are downstream of the hub, and then for the server to communicate with. So the server would, let's say in the case of a building automation system, the server would be the device that's hosting the building automation system's database, graphics, and things like that. And then the server is going to connect to the devices that are on the network through the hub.
Okay, thank you. The next question up is from Osa. Are you able to connect to many hubs? For instance, if you have multiple third-party providers to integrate data with?
Yes, and that's the purpose of the acceleration program, to help the interoperability between all those BACnet SC hubs. But the idea would be BACnet SC hubs would be able to talk to other BACnet SC hubs in a system.
Okay, great. Next question by Robert is, You show that you can have several devices connected together, sharing one physical connection to a switch. What is the physical communication connection between these devices? Is it Cat5 or 6?
So let's look at the example that's on my screen right now. So let's start at the firewall, and if you go from the firewall to the left, the green and the blue would basically be Cat5 or Cat6 cabling in a building. And then the SC protocol, which is in green, would run across that physical cable. And then on the left where this blue is, that is still a Cat5 or Cat6 cable. And that blue is just the BACnet IP protocol talking on that Cat5 or Cat6 cable. So the physical layer, if you will, in this case would be a Cat5 or Cat6. But like I mentioned earlier, it could also be a wireless network that's transmitting the protocol wirelessly. So that's one of the advantages of BACnet SC is it doesn't care what the physical medium that is used to transfer the protocol. It can be the wired, it can be wireless, it doesn't matter.
Okay, thank you. From David, the question is, all SC devices will incorporate IPv6?
Yes. Well, I mean, the short answer is yes, but I would also say it's going to be dependent upon manufacturers. That most manufacturers right now are in the process of implementing IPv6 in their devices. So with BACnet SC, IPv6 will be supported as well.
Okay, great. Question from James. Is there any benefit to adding SC to an existing network before an existing firewall?
Is there any benefit to adding SC? Well, I guess ask them to clarify when they say before the firewall going out to the network or before the firewall coming into the network. It doesn't matter. It can be in either place. It's really going to be a function of the SC implementation and how the manufacturer wants to do it.
Okay. Next up from David, the question is, can you still discover new devices?
So you will be able to discover new BACnet SC devices, and then I guess really the crux of this question might be in the example of the slide I have up here. I'm assuming if you wanted to add some sort of new BACnet MSTP device, or on the left-hand side here, if you wanted to add some sort of a new BACnet IP device, that's going to be a function of the BACnet SC router, whether it's an IP router or MSTP router, and the capability it has. I will assume that it would have the capability of discovering a new device that was added to that network. But in terms of BACnet SC devices, yes, you will be able to discover new BACnet SC devices as they're added to the network.
Okay, thank you. Next up, we have a question from Rick. Will BACnet SC devices carry a BTL mark?
BACnet testing laboratory. I'm not 100% sure. I think they will, because that will be a function of BACnet as well. Justin, you have any comments on that?
Yeah, I'd imagine they would, all the hub and physical hardware devices will be tested by the BTL and get the stamp, but might want to follow up with that one.
Okay. The short answer is I would say yes, that will be happening.
Okay, thank you. Next question from Stephen. Can BACnet SC be implemented on older systems, or would they need to be upgraded?
So that's the real advantage of BACnet SC. So I hate to keep pointing back to this slide that's on the screen, but if you've got existing like BACnet MSTP devices or existing BACnet IP devices, you can put in a BACnet SC router. So in the case of what's on the screen for the IP devices, you can put in a BACnet SC to IP router, and then all of the devices that are behind or downstream of this router would be connected through BACnet SC and have the BACnet SC security from the router out. And in the case at the bottom where you have the BACnet MSTP link, you would just put a BACnet SC to MSTP router and then connect out from the BACnet SC router, and then this network would be secured from the BACnet SC router out. And one thing I do want to point out is if you do have a system that has existing BACnet IP devices, you don't necessarily have to put in an SC to IP router for every BACnet IP device. You can put one BACnet SC to IP router for all of these devices.
Okay, thank you, Ken. Next question is from Emily. Can you elaborate on how BACnet SC is compatible with existing BACnet IP networks? Do we have to convert the existing BACnet IP to BACnet SC, or do they coexist?
So in simple terms, you could say they coexist. So what ends up happening is we're still on, so the case of what I have on the screen right now, like I said before, this green from the firewall to this BACnet SC IP router, and this blue from the SC IP router to these BACnet IP devices. This would be the customer's IP, existing IP network, if you will, a Cat5 or Cat6 cable, whatever the case may be. You put the BACnet SC IP router in on that network, and then what ends up happening is the BACnet IP devices talk to the BACnet SC IP router using BACnet IP, and then the BACnet SC IP router talks BACnet SC back to the hub. And once again, this is on the existing network infrastructure. The only change that has to be made, if you will, is the addition of the BACnet SC IP router, and then of course the requirement to have a primary hub to manage the data, or to manage the traffic, excuse me.
Thank you. Next question is from Mark. What about ring topology?
Ring topology is going to be a function of, I guess, manufacturers and how they want to implement it. That is something that can be used, but I guess I would also clarify, are you going to use the ring topology with, I guess, what's called the ring protocol? But you could, if the manufacturer will allow it, you could use ring topology with BACnet SC devices being on the ring. Justin, you want to add anything to that?
Yeah, that's what I would say. It, ring is I think it's a layer 2 protocol. So BACnet would SC was an application layer, so it would run on any ring type protocol. The ring is managed through the switch, closes your switch ports and opens and closes them. So I don't see any issue with running BACnet SC on a ring protocol.
Okay. Next question is, so there are no broadcasts anymore?
That is correct. There's no BBMDs, broadcast, BACnet broadcast management devices, and the distribution tables that go along with it. That doesn't occur with a BACnet SC implementation.
Okay, our next question is from Helen. Was this presentation recorded and can we get access to it?
I'd have to defer to Courtney on that one. I assume so.
We have confirmation that yes, it has been recorded. And we can make that available. Okay, we are technically out of time. I'll throw another couple of questions on here, but we do want to respect your time. So we'll go for another couple more here.
Okay.
This next question is from Cullen. When connecting BACnet MSTP networks through a BACnet SC router, will a BACnet device table need to be established?
No, because you're using the table when you're trying to broadcast across multiple networks. And with BACnet MSTP devices connected to the BACnet SC router, that is one network. So all of those devices would just connect to that SC router. There won't be a need for a broadcast table or distribution table because you're not trying to go across networks.
Okay, the next question is, did BACnet SC is MQTT supported?
MQTT. I do not believe so. That is typically used in cloud client server type situations for messages or connections between the cloud and like a thermostat or a device in the building.
Okay, our next question is from Zahir. If any device fails for any reason on BACnet SC network, what will be the impact on the other devices on the same network?
So the BACnet SC devices will continue to communicate with each other, and then the devices that are behind the BACnet SC router would continue to function in a standalone methodology without connection to an upper level controller or to the server, if you will. But in the case of what's on my screen, if well, let me go to right here on your screen. If one of these BACnet SC devices were to stop talking, the other devices would continue to talk.
Okay. Next question from Benjamin. Will the IT folks at the cloud data center where VM server is know how to put in the hubs?
Say that one more time now.
Will the IT folks
installers?
at the IT folks at the cloud data center where the VM server is know how to put in the hubs?
Yes, because that hub installation is going to be a function of the manufacturers that are providing the hub and their server software or their application software that sits on the VM server.
Okay. From Daniel, can there be an issue switching over existing networks to BACnet SC with existing BBMDs?
No, not as long as you implement the BACnet SC routers and devices and hubs for the networks that you have. You should not have a problem doing that.
Okay. From Jared, the question is, you will still need BBMDs in a BACnet SC over IP router, correct?
No, you would not. Because once again, BBMDs are typically used to push or manage data across multiple networks. Keep in mind, with a BACnet SC installation, you're segregating your network with a BACnet SC device and hub.
Okay, and for the sake of time, since we have definitely run over, this will be, well, I'll make 2 questions left here. From Patty, if you had an existing install, had multi-VLAN, would you recommend multi-SC over IP routers, or is it possible to maintain BBMD in the IP side?
I would recommend implementation of SC across the board. If you're going to start, the good news is you can implement BACnet SC in segments. You don't have to do it across the board, but the ultimate goal should be to move directly to a BACnet SC implementation so that you can alleviate the troubles and headaches that go with managing VLANs and those networks.
Okay, great. And for our final question from Joseph, is there a limit in MSTP devices that can be connected to one router?
I would say that's going to be dependent upon the manufacturer and what they allow. And that same would apply to a BACnet SC IP router. I'm not sure how all the manufacturers are doing their designs and implementation, so they could potentially have limits on the number of devices that they allow. But also keep in mind with an MSTP link, MSTP links only allow a certain number of controllers on that link. So that would also be a function of the MSTP installation as well.
Okay, great. Thank you, Ken. We have definitely run out of time, and there are quite a few more questions here. I believe, Ken, we had a plan for handling the remaining questions after the broadcast.
Yes, if you do have remaining questions, we'll get a list of them, and we'll be sure to respond to those questions probably over the next week.
Okay, great. At this point, I guess, will I be turning this back over to Austin?
Well, before Austin gets on, once again, thank you everybody for your time. I hope you found this helpful. We're very excited about the implementation of BACnet SC and what it's going to do for our industry and help bring us to some current accepted IT practices and being able to secure BACnet networks. So thanks everybody. Austin?
All right. Just BACnet McKenna said, thank you everyone for joining us.